Welcome to Study Spectrum. We'll be taking geometry for 10th standard today. The topic for the day is similarity. I'll start with the triangles. We all know triangles. Plus we need to understand the ratios also. Two triangles when we consider at a time, and when we divide the area, we get a ratio. So today's topic of similarity is triangles. We'll be talking of properties of the ratios of two triangles. There are basically four properties. I'll start with property 1 of two triangles. As I said, when we compare two triangles, we obtain a ratio. Now if there are two triangles given, as usual we write triangle ABC and PQR. Now in these two triangles, if there is a height also given to us, we all know to draw a height, I need to draw a perpendicular. So from vertex A and vertex P, I have drawn two perpendiculars. And if I name this triangle as A1, area of this triangle as A1, and area of other triangle as A2, base if I take as B1 and B2 for these two triangles, and height as H1 and H2. Then as per property 1, ratio of the areas, area of triangle ABC, area of triangle PQR, ratio of the areas of these two triangles becomes base into height upon base into height. So when we are comparing these two triangles, this is base is BC, height is AD. For triangle PQR, base is QR and height is PS. So ratio of areas of two triangles is equal to product of base and height of those two triangles. This is property 1 for similarity. As you know, base is mentioned as B1, height is mentioned as H1. So this can be written as B1 into H1 and B2 into H2. So area of triangle ABC upon area of triangle PQR becomes B1 into H1 upon B2 into H2. This is our property number 1. Clear? Area upon area, base into height, base into height. We all know height is always on base. So for base BC, height is AD. For base QR, height is PS. Property number 2. Again of two triangles. But this time, we are adding certain thing on it. That addition is base are equal for both the triangles. So this time, triangle ABC, other triangle is PQR. Same way, area is A1, area is A2, base B1, base B2, height H1 and height H2. But as I said, we have added one condition. The condition is base are equal. That means known to us B1 is equal to B2. With these two triangles, B1 is equal to B2, or we can say BC is equal to QR. As bases are equal, so we can write area of triangle ABC upon area of triangle PQR equals to height upon height. So in this case, this point we have taken as D, this point we have taken as S. This becomes AD upon PS. Or we can write area of triangle ABC upon area of triangle PQR as H1 upon H2. That means when base are equal, ratio becomes height upon height. So by now two things we have done. First, area upon area, base into height upon base into height. Second one, area upon area is equal to base upon base. Sorry, area upon area becomes height upon height when bases are equal. Property number 3, again of two triangles, but this time, last time we have taken base as equal, this time we are taking heights as equal. Heights are equal. So I am taking two triangles, ABC, PQR again, but this time heights are equal. So ABC, point B, point S. So I am writing over here H1 equals to H2. Last time it was B1 equals to B2. This time it is H1 equals to H2. Heights are equal. Area triangle ABC, area triangle PQR, as heights are equal, I can write this ratio as base upon base, BC upon QR. You can identify yourself, BC and QR are base. So area triangle ABC upon area triangle PQR equals to base upon base. So if you're taking this as B1, this as B2, we can write this as B1 upon B2, and this is your height, H1 and H2. Fourth property and the last property of two triangles. In this, we are going to take bases equal and heights equal. So I have taken two triangles. Same way PQR, ABC, heights are drawn. I'll name them B1, H1, B2, H2. Base, base, height, height we have taken. Now in this case, area of triangle ABC will equal to area of triangle PQR. ABC will equal to area of triangle PQR, because base and heights both are equal. B1 is equal to B2, H1 equals to H2. So there are four properties we have done. Quickly we'll revise all four. Property 1, ratio of areas of two triangles is equal to base into height upon base into height. Property number 1. Property number 2, area upon area is equal to base upon base when heights are equal. Sorry, I'll go again. Area upon area is equal to height upon height when bases are equal. Property number 3, area upon area is equal to base upon base when heights are equal. Property 2 was when bases are equal. Fourth and the last property, area is equal to area when base and heights both are equal. So before starting main content of similarity, you all need to know the properties of ratios, which are area upon area, B1 into H1 upon B2 into H2. Area upon area is equal to H1 upon H2 when bases are equal. Area upon area is equal to B1 upon B2 when heights are equal. And the fourth one, area is equal to area when base and heights both are equal.
Lot of students waste their precious time watching cartoons, movies, reality shows on TV. Then they waste their time on social networking sites. When the students sit to study, they are unable to concentrate to get your studies finished, and they get low marks in exams. Parents shell out tons of money from their pockets for coaching classes. But who knows what is taught in these classes? Teachers at times get bugged up when you ask them questions. YouTube has a lot of information but little of use. This is where Study Spectrum TV channel comes in picture. Every chapter explained by different teachers with different examples and repeat telecasts. We remember 20% of the audio ads we hear, 30% of the printed items we see. But we remember 70% of the audio visuals. That is why video teaching is a powerful medium to learn. After watching Study Spectrum TV channel, you get a peaceful sleep with no tensions and no worries. You devote less time towards your studies and you get better marks in your exams. Visit us on www.studyspectrum.com. Follow us on Facebook. So what are you waiting for? Subscribe for Study Spectrum TV channel and keep edifying.
We'll move on. Just now we have done 4 properties of triangles in relation to area and ratio. Now I want to talk more about altitude. Being in 10th standard, it is important that the concept has to be very clear of altitude. For that, I am taking 2 triangles. In the first triangle, I am taking the midpoint of this base, and in second triangle, from the opposite vertex, I am drawing a line. This line will be the altitude for this triangle. You can call it altitude, you can call it height of this triangle, and the midpoint and opposite vertex line which is joined, that is called as median. And this is called as altitude or height of the triangle. The strange thing is, this triangle has got 3 different heights. This triangle has got 3 different altitudes. For example, same triangle. If from this vertex, if I draw a perpendicular line, this will be the altitude and this will be the base. In simple words, this will be the height of the triangle, this will be the base of the triangle. For this triangle, this is the height, this is the base. When we take these 2 things at a time, this is called as correspondence. So in correspondence to the base, this is the height. In correspondence to this base, this is the height. Base, height, base, height. Yeah. Okay. I want to take a triangle and I want to speak more on base and height now. Now in this triangle, normally we write ABC only. So ABC, PQ. There are actually 2 triangles. One of the triangle is APQ, the other triangle is ABC. Now these 2 triangles have different bases, different heights. So for triangle APQ, if AP is the base, and for triangle ABC, let's say AB is the base. What's happening is, for base AP, the height is from Q, 90 degree. So for triangle APQ, base is AP, height is from Q. And if I join BQ also, you will note that AB is the base for triangle ABQ and the height is this only. Sometime back I have taken one example. Base, height has to be from opposite vertex, 90 degree. If this is the base, this is the height. For vertex, for base AB, the height is from Q. If this is the height, base is AB. So for these 2 triangles, if you observe, height from Q is same. And if you name this point as M, you will observe that QM is a common height for base AP and for base AB. In other words, these 2 triangles have equal height. Which 2 triangles? Triangles APQ and triangle ABQ. These 2 triangles have got equal height. And when heights are equal, ratio is base upon base. Same thing happens other way also. If we draw a perpendicular from point P to side AQ, and if we join P and C, that way also we'll get 2 triangles APQ and triangle ACP. This was important because next what we are going to do is basic proportionality theorem, which is the foundation for similarity. So you all need to understand the concept very well. Basic proportionality theorem. this is one triangle. In this triangle, I've taken a side PQ. Rather, I've drawn a line PQ. If you extend this line both ways, and you can name this as L. So in triangle ABC, if line L is drawn parallel to BC, triangle ABC, line L parallel to BC, then what happens is ratio AP upon PB equals to ratio AQ upon QC. This is the outcome of basic proportionality theorem. That is, in a triangle, if line is drawn parallel to a side, other two sides are divided into same ratio. You can make out in triangle ABC, line is L is parallel to side BC, other sides, that is side AB and AC, those two sides are divided into same ratio. That is AP upon PB is equal to AQ upon QC. Let's do the proof also for this theorem, very important. We'll take the proof also for this theorem. For the proof, what we are doing is, we are taking triangle APQ and triangle ABC, triangle APQ and triangle ABQ. For that we need to make a small construction, that is, we'll be joining B and Q. So I have joined B and Q. So what I am doing is, I am taking triangle APQ and triangle ABQ at one go. Now we can make out APQ triangle and ABQ triangle have equal heights. These two triangles have equal heights. That height is from Q, from vertex Q. If I draw a height, that height will be for base AP and the same height will be for base AB. So these two triangles have equal heights. Therefore, area triangle APQ ratio area of triangle ABQ becomes base upon base. That is AP upon AB. Why? Because triangles have equal heights. Some time back we have done in property 2 and 3 that triangles have equal height. Ratio of the areas of triangle becomes ratio of the base. So this time triangles have equal height. So area ratio becomes ratio of base. I'll mention the reason. Triangles of equal heights. This is the reason for this ratio. Let's name this as first equation. For the second case, I am joining P and C also. Join CP. This time, triangle APQ. You can make out triangle APQ coming before also. Last time we have taken triangle ABQ. This time we will take triangle ACP. Triangle ACP. Triangle APQ and triangle ACP again have equal heights. Heights of these two triangles are same. Which two? Triangle APQ and triangle ACP. APQ and triangle ACP has got equal heights, and that height would be from point P. If you make out, this is the height for these two triangles. From vertex P, if you draw a line perpendicular to AQ, that will be height for triangle APQ, and the same will be height for triangle ACP. Now if triangles have equal heights, again ratios would be equal. Ratio of those two triangles will equal to ratio of corresponding base. So area triangle APQ upon area triangle ACP will be base upon base. This time base are AQ and AC. This is our second equation. Reason is triangles of equal height. Now we got two equations. In these two equations, one side we have triangle APQ, in second equation also we have got triangle APQ. Now what we can do is, we can multiply these two equations. We can multiply these two equations. Now if you multiply these two equations, multiply equation 1 and 2. So we get area triangle APQ upon area triangle ABQ into area triangle APQ So next we'll start basic proportionality theorem. As I said, this theorem is very important for this chapter, similarity. In fact, this is the foundation to understand similarity. Basic proportionality theorem says that in a triangle, if a line is drawn parallel to one side of a triangle, the remaining two sides are divided into same ratio. As you can make out, in triangle ABC, PQ is drawn parallel to BC. PQ and BC are parallel. Other sides, AB and AC, that ratio is divided into equal parts. In other words, AP upon PB becomes AQ upon QC. That ratio becomes equal. So AP upon PB is equal to AQ upon QC. This we need to prove. This is what basic proportionality theorem says. We have made a construction, that is join BQ and CP. So we have joined BQ and CP. So I'll take triangles APQ and triangle BPQ. You can make out there are two triangles, APQ and triangle BPQ. Now these two triangles have equal heights. I'll take one example. Say this is a triangle and this is another triangle. So triangle ABC and triangle ABD. For these two triangles, if I draw a height from vertex A, if I draw a height for triangle ABC and triangle ABD, we can make out this height is common for both the triangles. Which two triangles? Triangles ABC, for that triangle base is BC, and triangle ABD, and for that triangle base is BD. For these two triangles, height is same. So ratio of areas becomes ratio of base. Base are BC and BD. Hope you have understood. The same thing we are going to apply it over here. The same concept we are going to apply over here. So I'll clean out this part. Look at now triangle APQ, and the second triangle is triangle BPQ. these two triangles have equal heights. And that height, if I can draw from vertex Q to base AP. Therefore, area of triangle APQ upon area of triangle BPQ. As we said, if heights are equal, area becomes base upon base. So base is AP and base is PB. These are first equation. Reason is triangles of equal height. These two triangles have equal height, so ratio becomes base upon base. Same way, we will take triangle APQ. Last time we had taken triangle BPQ. This time we will take triangle CQP. Triangle CQP. These two triangles also have equal heights. And that height will start from vertex P. From P, we can draw a height. That height will be common for base AQ and base CQ. Therefore, area triangle APQ upon area of triangle CQP becomes base upon base, and we can make out base is AQ and QC. AQ and QC. This is our second equation. Reason is same. Triangles of equal height. Also, look at two triangles BPQ and triangles CQP. Triangle BPQ, triangle CQP. If you look at these two triangles have common base, and that common base is PQ. For triangle BPQ, PQ is the base. For triangle CQP, PQ is the base. So triangle BPQ, triangle CQP have common base, that is PQ. So I'll mention that triangle BPQ, triangle CQP have common base. Again, if you concentrate on these two triangles, you will observe that as these two lines are parallel, so their heights are also same. For triangle BPQ, height will start from vertex P. For triangle CQP, height will start from vertex C. Now these two heights are also same. Why? Because these two heights are coming between the parallel lines. So BPQ triangle, CQP triangle have common base and equal heights. Heights are also equal. Now when triangles have equal base and equal height, their areas are equal. Therefore area triangle BPQ is equal to area triangle CQP. This is our third equation. Now look at first, second, third. First equation, in the denominator we have triangle BPQ. In the second equation, in the denominator we have triangle CQP. BPQ, CQP. Triangle BPQ is equal to triangle CQP. So if we apply all three equations at one go, if we apply all the three equations at one time, we'll come to know that left hand side of first equation, left hand side of first equation, left hand side of second equation, the only differences of triangle BPQ and triangle CQP. Triangle BPQ and triangle CQP both are same, and the difference is of only that these two triangles, but these two triangles are same. So when we apply all three equations at one go, we'll come to know that left hand sides are equal of equation 1 and 2. Therefore, AP upon PB is equal to AQ upon QC. This is by applying all three equations at one time. And this is what we were looking for. AP upon PB is equal to AQ upon QC. Again, I'll sum it up. Basic proportionality theorem says that in a triangle, if lines are parallel, sides are in proportion. Again, in a triangle, if lines are parallel, sides are in proportion. Over here, lines were PQ and BC and sides were AB and AC. In proportion means AP upon PB is equal to AQ upon QC. Next is converse of basic proportionality theory. It's just the converse of what we have done some time back, that is basic proportionality theory. So I'm taking triangle ABC. I'm drawing a line L which has got 2 points P and Q on side AB and AC. So given to us triangle ABC, line L is there with point P and Q on AB and AC. Known to us AP upon PB is equal to AQ upon QC. This is known to us, that ratios are equal of sides. Then by using converse of basic proportionality theorem, we can say that line L is parallel to side BC of triangle ABC. This is by converse of basic proportionality theorem. So we have done two important theorems. First was basic proportionality and the next was converse of basic proportionality theorem. So I hope this concept is clear to all of you. Basic proportionality, converse. Before that we have done the properties of triangles also. Now I want to take some problems just to make you feel more comfortable with basic proportionality theorem. Say in these two triangles, in figure 1 and in figure 2. Say it is known to us that this line L is parallel to one side. This is known to us, line L is parallel to BC. And in this triangle, known to us, line L is parallel to QR. Say this value is 5. This value is 15. This value is 30. And say this is X. In second case, say this is Y. This value is 6. This value is 2. And say this value is 8. In first figure, we need to find out X. In second figure, we need to find out Y. Now in first case, in triangle ABC, L is parallel to BC, known to us. We can apply basic proportionality theorem, which says that if lines are parallel, sides are in proportion. Therefore, we can say that 5 upon 15 equals to X upon 30. How we got this ratio? We got this ratio by using basic proportionality theorem. If we move further, 5 upon 15 will be 1 upon 3 and this will be X upon 30. And when you cross multiply, you will get X as 30 upon 3, value of X will be 10. So we got value of X as 10. How we got this as 10? By applying basic proportionality theorem. So you must be understanding that in a triangle, if lines are parallel, directly we can write the ratios. Now we'll take the second case also. In second case, triangle PQR is given to us. In this triangle PQR, line L parallel to QR, this is known to us. Line L is parallel to QR. Therefore, ratios will be equal. We can say that 6 upon Y equals to 2 upon 8. 6 upon Y is equal to 2 upon 8. Moving on, this is by using basic proportionality theorem. Moving on, we can write y equals to, if we take y this side, 6 into 8 upon 2, this will give you 2. If you divide this, 2 into 4 is 8, you will get answer as 24. So what we have done in these two sums, we have applied concept of basic proportionality theorem. Okay, so let's do some application of converse of basic proportionality theorem. That is, we need to find out whether lines are parallel or not. I'll take one triangle PQR and I'll take some values. Let's say in triangle PQR, EF, E and F are points on PQ and F is point on PR. And I'm joining these two. Let's apply converse of basic proportionality theorem to find out whether line EF is parallel to line QR, whether these two lines are parallel or not. Some values are known to us. Values are, for values PE is 3.9, for value EQ is 1.3, value for PF is 3.6, and value for FR is 2.4. These are the values known to us. Our objective is to find out whether line EF is parallel to line QR or lines are not parallel. Let's find out the ratio. PE upon EQ. Ratio will be 3.9 upon 1.3 because values are 3.9 and 1.3. We can multiply and divide numerator and denominator by 10. We'll get 39 upon 13. What we have done is we have multiplied 3.9 by 10. Same time we have multiplied 1.3 by 10. Going further, 13 into 3 is 39. 3 upon 1 is the ratio. The simplest ratio is 3 upon 1 for PE upon EQ. Now we'll find out ratio for PF and FR. PF and FR. Values are known to us, 3.6 and 2.4. Same thing I've done, multiplying and dividing by 10, 36 upon 24. So 12 into 2 is 24, 12 into 3 is 36. What answer we are getting is 3 upon 2. In previous case it was 3 upon 1. 3 upon 1, 3 upon 2, both are not equal. Therefore, PE upon EQ ratio is not equal to PF and FR ratio. Therefore, we can say that lines are not parallel. Why lines are not parallel? Because to be lines parallel, it is important that ratios should be equal. Over here, ratios are not equal. Had this been 3 upon 1 equals to 3 upon 1, our answer would have been lines are parallel, but answers are different, so lines are not parallel. Just to understand this better, I'll take one more example. Again, for triangle PQR, point EF is on triangle PQR. This time, I'll change the values. Values are 4, 4.5. For value PE is 4, this is 4.5. Other values are 8 and 9. So I've got the 4 values. Now let's calculate. Let's find out whether ratios are same or ratios are not same. PE upon EQ equals to, this time we have 4 upon 4.5. What I'll do is I'll solve this. Before that, I'll put the values for PF and FR also. PF upon FR. PF and FR is there, this side. 8 upon 9. Now we have to solve it further to find out whether we are getting the same ratio or different ratio. 4 means 4.0. We all know this. So to remove this decimal, I have to multiply numerator and denominator by 10. So this becomes 45 and this becomes 40. Now we can make out common multiple is 5 for both. 5 8s are 40, 5 9s are 45. 5 into 8 is 40, so we got 8. 5 into 9 is 45, so we got 9. 8 upon 9, PF upon FR is also 8 upon 9. So this time, PE, EQ ratio is equal to PF, FR ratio. Now we know this, that if these ratios are equal, lines has to be parallel. Therefore we can say that EF is parallel to QR. How we got this answer? By applying converse of basic proportionality theorem. So we have done some applications for basic proportionality and converse. So we can make out if ratios are same for two sides, lines are parallel. And if ratios are not same, like in this case, this ratio was different, answer was different, lines are not parallel. So already we are through with basic proportionality theorem and converse of basic proportionality theorem. Now based on basic proportionality, we have some applications. In fact, there are two applications. The first one is property of intercept. Property of intercept by three parallel lines. And the second one is property of angle bisector of a triangle. Property of an angle bisector of a triangle. Based on basic proportionality theorem, we can have two more applications, two more properties. I'll talk of first one first. As per this property, if there are three lines which are parallel, for example, if I've taken three lines, I'll name them as L, M and N. If there are three lines L, M, N and these three lines are parallel, and if I draw two transversals on these two lines, passing through L, M and N. If I draw two transversals intersecting lines at points A, B, C and D, E, F. Again I repeat, known to us, line L parallel to M, parallel to N. These three are the lines which are parallel to each other, and there are transversals drawn. Now if we apply this property, we can say that AB upon BC, this ratio is equal to DE upon EF. Ratio of AB upon BC is equal to DE upon EF. This is by applying property of intercept by three parallel lines. I'll take some examples. Say, known to us, this is a trapezium. Known to us, this line is parallel to this line. Now over here, when these three lines are parallel, these ratios will be equal. If I name this as small letter, A, B, C and D. If these three lines are parallel, these ratios would be equal by applying property of intercept by three parallel lines. The next is property of an angle bisector of a triangle. There is a triangle given. I'll name this triangle again ABC. B is the vertex. From B, say there is an angle bisector drawn, and that angle bisector is intersecting side AC at point D. Now as I said, angle BD is an angle bisector, so these two parts are equal. So known to us, triangle ABC, BD angle bisector. Then if you are applying property of an angle bisector of a triangle, we can say that AD upon DC, that is the side which is divided, is equal to AB upon BC. This is by applying property of an angle bisector. So you can make out bisector, the side which is being divided by the bisector, this time side AC, division is AD and CD. This ratio is equal to remaining side ka ratio. This is how this property we need to apply. You also need to make out, say if you start from AB, so your answer will be AB upon BC is equal to AD upon CD. Again I repeat, if you are starting from CD, our answer will be CD upon AD is equal to BC upon AB. This is property of an angle bisector of a triangle. So what we have done, we are doing applications of basic proportionality theorem. Why applications? Because these two results we have got from basic proportionality. The first one is property of intercept by three parallel lines. Second is property of an angle bisector of a triangle.